have the right amount of carbons, just so that you're not too confused about that. And this is actually question number 3. Sorry about the miscount. Yep, 3. And we have another IUPAC naming question. So we have this, okay? Now the tricky about this, well, not tricky, but the trick about this is you want to make sure that you're actually able to draw out what they're saying. So first, state the correct IUPAC name, okay? And we have now, if we wanted to just really draw it out, we have a CH3 connected to CH, so it's like that, alright? And this thing is now connected to a CH again, but as you notice, because it was part of this bond, we have 1, 2, 3, 1, 2, 3, 4. It's going to look like 1, 2, 3, 4. So let me just move this down a little bit, just so I can fit all of these. Okay, this is what we have so far. And then we have now something that looks like 1, 2, 3 more. So 1, 2, 3. So 8. 1, 2, 3. Okay. And as first one, we have something that sticks out like this. Okay. And then on the last one, we have it go like 1, 2. Sorry. And then above it, we have it going 1, 2, 2, 3. So we're doing some tricky little something like this, okay? And if you count it, we should have the same amount of carbons as the picture. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So 16 carbons in total. And here we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So we both have 16 carbons in both pictures. It's just important to be able to recognize them. Because I drew it out like this, I know it can be confusing. So I do highly recommend that if you feel more comfortable, you write the whole CH3 and then you draw the bond. Or even better yet, you actually draw in terms of like that. Just so that way you know the hydrogens are attached and that's how much space you have for that bond there. And you kind of just connecting and connecting just to make sure that you have the appropriate amount of carbons before you start solving. So the first things first is to find our longest chain. So our longest chain here would be probably something that goes from here to here. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So we have 12. Now to find out which end we start with, we have to make sure that you see the parts where you have something attached. So like we have this part now that's not accounted for, and this and this. So those three aren't accounted for. We have to find a way to account for them. So to make sure that we start from the right end, we add up the numbers of the carbon that it's located on and see if when we start from the other way, we can get a lower number, okay? So right now we have 5 plus 6 plus 9. So we put that into the calculator, 20. But now what would happen, what would we get if we flipped it over? So instead of 12, we now had 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So now we have 4 plus 7 plus 8. $19. So barely, but we do have to go about then in regards to the red, because the red gives us the closest thing in regards to I guess the lower number the better. That's how you can signify as better structuring. So with that, oh sorry, I'll keep that 4 there. With that being said, now let's find out what's attached to each part, okay? So first of all, to figure out what the longest chain is, it's 12. So to just emphasize again, meth is 1, eth is 2, prop is 3, but is 4, 5 is pent, 6 is hex, 7 is hept, 8 is oct, 9 is non, and 10 is dec. And then 11, I honestly forget, it's like undec, that's 11, and 12 is dodec. Okay, so with that being said, this has 12, so this would be dodec. And the key thing is that if you look closely, right, you see that it's all CH2s, CH and everything. There should be no double bonds in it, okay? So that will be dodecane, okay? That would be that long chain part. But what do we have in the part sticking out? On 4, we have, since eth is 2, we have an ethyl group. 1 ethyl group at 4. At 7 and 8, we have 2 methyls. So you have to now remember the order this would go by, considering that when you actually try to put it there, you have to remember it's alphabetically. So now we have ethyl is the only one at 4, so we have 4 ethyl, and then 7, 8 dimethyl, and then dodecane. So this is the answer we should get for this formula. That would be the IUPAC name. The important thing you have to memorize here is that as you're solving for this question, you want to make sure that you're accounting for everything, okay? And that way you are less likely to get lost. So let's see here how we did. Which one gives us that name? So we have a 6,7-dimethyl-3-propylundecane. Something that does not look familiar at all. Next one is 4-F-methyl-dodecane, which would make it B, because that's the only one that matches so far. Then we have 5,6-dimethyl-dipropylundecane. I don't know, let me show what it's about, but it doesn't sound correct. Ethyl 1,10-ethyl 5,7-dimethyl-dodecane. So somehow by her, somehow here, 10-ethyl 7-dimethyl-dodecane, somehow they got some very different numbers. In fact, yeah, I wouldn't even know how they even got the answer. But nonetheless, we now have our full things that we've gone through. And with that being said, this 4-ethyl 7,8-dimethyl-dodecane only matches B. So that B is the right answer here. So now question 4 is asking us, let me just quickly say that this is correct. Large continuous chain, and then number E. I wish I could have seen it, but this is correct. That's, at least they approach it correctly. So now, question number 4. Sorry about that.